latency. I mean, it's the absolute enemy of AV over IP, isn't it?
It's the killer. Absolutely.
You can have this, perfect 4K image, but if you're trying to use a keyboard and mouse and the signal lags, the whole system is basically useless.
It feels mushy. And that's exactly the headache we're looking at today with this PureLink VIP-ExT-T400-2 solution.
It's quite a mouthful.
It is, but it's definitely aimed at that high-end, commercial install market. We're looking at a Wallplate encoder that pairs with a scaling decoder.
And that scaling part is important, I'm guessing?
Oh, it's critical. It's what bridges the gap between, say, an older piece of hardware and your brand new 4K displays. The whole network doesn't have to default to the lowest quality source.
Right. And speaking of quality, looking at the specs, they are not holding back on the visual side. It supports 4K 60, 4.4.4 HDR.
Yeah, and that 4.4.4 chroma subsampling. That's the detail that matters.
Because usually pushing that over a standard 1 gig network is where you start to see issues, right? Compression, artifacts.
That's the trade-off, exactly. But they seem to have optimized it. For something like medical imaging, where color accuracy is just non-negotiable, you need that full color data.
Okay, but let's go back to the latency, the thing I started with. The spec sheet says ultra-low latency, less than 17 milliseconds.
Uh-huh.
Now, in the gaming world, that sounds pretty good. But for a professional KVM setup, is 17 meters actually tight enough?
It is. It's right at that threshold of being imperceptible. I mean, anything under 20 milliseconds, the human brain just can't really detect it. It feels instant.
So if you're controlling a server that's 3 floors down...
Your mouse cursor moves exactly when your hand moves. No disconnect. If that number was, say, 30 or 40 meters, you'd feel it. And for a control room, that's fatal.
The documentation also mentions 2 ways to deploy this. You've got the standard point-to-point.
Right, over a Cat 6A cable. Gives you about 120 meters.
Pretty standard stuff for an extender.
Correct. That's sort of the basic balloon replacement. But the real utility, the interesting part, is running it over a 1G IT network.
Okay, and why is that so much better?
Well, for one, it doubles your range to 240 meters. But more importantly, it changes the entire topology. You're not just extending a cable anymore.
You're creating a node on a network.
Exactly. And that's what leads us to the scalability, which is, this is where it gets a little mind-boggling.
The datasheet says it supports up to 999 sources and 65,000 displays.
A staggering number, right?
Yeah.
This is where it stops being an extender and becomes a full-on matrix solution. You're not just sending video from A to B.
You can route any source to any destination.
Instantly. A facility manager can reconfigure an entire video wall without touching a single physical cable.
But managing 65,000 of anything sounds like a software nightmare.
Well, and that's why the integration part is probably the real selling point here. It works with PureLink's own Icon platform, but crucially for system integrators, it supports Crestron and QSYS.
So you can just drop it into an existing campus-wide system.
Exactly. It makes adoption so much smoother.
And speaking of campus or even government installs, we have to mention the TAA compliance.
That's just a mandatory checkbox for any federal or military contract. It means the supply chain is secure. You combine that with its 247 duty cycle rating, and you're squarely in mission-critical territory.
Which I imagine is reflected in the price. We're looking at just over $3,000 per unit.
It's a significant investment, no doubt. But you aren't paying for a simple HDMI extender. You're paying for that reliability, the scaling, and the compliance.
The cost of downtime would be much higher.
It would dwarf the hardware cost.
Oh.
Plus, a 3-year warranty suggests they really stand behind that uptime.
It really just highlights this whole shift in infrastructure, doesn't it? Moving away from those messy, centralized matrix switchers.
Absolutely. Towards this decentralized, network-based AV over IP, it actually changes how you think about a building's architecture. The computer doesn't even need to be in the same room as the user anymore.
It just becomes a resource you access on the network, not a box under your desk.
Precisely.
Which leaves us with a really interesting thought then. If we can route, 65,000 screens with near zero latency over a standard network, does the physical location of our computers and our media players even matter anymore? Are we finally at the point where the entire building is just one giant invisible computer?
With latency this low, I think we're already there.
A fascinating place to be. Thanks for breaking all this down with us today.